Okay, so we've successfully designed our circuit and breadboarded our circuit and written our software, and now we're ready to load our hex file into the 18F4550. Please see my previous video series on the Blink demo board if you'd like more detail on how to load software with either the PIC18F or the PIC18F3 into the 18F4550. Today I'll be using the PIC18F2. You could use the PIC18F3 if you prefer. And we have it connected to our breadboard. So now we're going to open our PIC18F2 programming software. And it'll take just a moment to come up. And there we are. So we see under device the PIC18F2 auto detected, the PIC18F4550, PIC18F2 found and connected, PIC device found. So now we're going to go to File and Import Hex, and we're going to navigate to the directory on the desktop where we got our hex file compiled to earlier, 18F4550 IO demo board. And there's our hex file. Double click on that. Hex file successfully imported, so now we're ready to write. And that'll take just a moment. Verifying device, programming successful. And so the next step here is we'll check the on power box at 5 volts and pan back down and look at our board. So with switch 1 in the off position, that's our slide switch here, we won't have any LEDs on because we're in digital mode. So if we press either switch 2 or 3, we'll see the first 4 or second 4 LEDs light up. We can even press both at the same time if we like. So that's working great. So now if we change switch 1 to on, we're now in analog mode. Now at the moment the potentiometer is turned down all the way to 0 volts. So if we slowly turn it up, we should be able to count our binary numbers on these LEDs from 0 through 255. So let's turn very slowly. I'll try and get to 1 first. There we are. 1, 2, 3, 4, 5, 6, 7, 8, and so on. So if we turn our potentiometer right about halfway up, we should see either 127 or 128 on our LEDs. Not quite there yet. And we're almost halfway, a little bit farther. And I went a little too far. And there's 127 on our LEDs. And there's 128. And as you can see, or I'm not sure how well this shows on camera, but the potentiometer is dead on halfway up now. So that's working great for us. And if we turn our potentiometer all the way up, we should get 255 on the LEDs, which of course is all of them on. And there we go. So as you can see, the response of the LEDs, if I turn the potentiometer back and forth pretty quickly, the response of the LEDs is excellent. There's really no perceptible timing delay. So those variables that we chose earlier for our analog to digital converter timing have worked out real well for us. And of course we can go back and forth to digital mode again if we like. And back to analog mode just to test the switch one more time. Still working great. So it looks like our breadboard program and test session was very successful. Definite thumbs up on that. And now we're on to our perfboard version. So now that we have successfully breadboarded and tested our circuit and software, we can move on to our perfboard version. If you're relatively new to soldering and perfboarding, for example, if the Blink demo board was the first circuit you had perfboarded, this would be a great second circuit to perfboard. Compared to the Blink demo board, we have some additional parts on our board and some additional traces and wires to run, but our board is still relatively uncrowded, leaving us plenty of room to work with. And so once we've successfully perfboarded our circuit, we can load our software into the 18F4550 and test. So here we have the perfboarded version of our circuit, and of course we have our trusty PIC18F2. So we're going to plug our PIC18F2 into the 6-pin programming header on our board. And there we go. So now we're going to go to our desktop software to load our hex file into the PIC18F2. Final tripod adjustment there, that's good. And PIC18F2, take just a moment to come up. And we can see our 18F4550 has been auto-detected, PIC18F2 found and connected, PIC device found, file import hex, same hex file as before. It'll take just a moment to write. And programming successful. Now we'll turn the power on at 5 volts and pan back down to our circuit board. Get zoomed in on this nice. And that'll work. So with switch 1 in the off position, we're now in digital mode, so we can actuate our 8 LEDs with our 2 nice tack switches. And if we enter analog mode, we can sweep our potentiometer from 0 all the way up to 255. And there we go, and we can sweep back down to 0 if we like. And then we can go back to digital mode, and that still works great. So our perfboard test is complete and a definite thumbs up. Congratulations! You now know how to make a demo board and write software for the 18F4550 with both digital and analog input. So, what's next? In our third demo board video series, we'll add USB communication with a desktop or portable computer. Stay tuned.